this magenta color. There we go. All right, so the rules for radicals with adding and subtracting are the same rules as fractions. You have to have a common radicand, and the radicand is the number that's underneath the radical. So because all of those are 7s, you just go straight across and add or subtract the front numbers. So that's 4 minus 11. Take that answer and then subtract 13. So 4 minus 11 is -7. And then if we subtract 13 more, we get -20. So -20 goes out front, and then the square root of 7 just stays as your answer. And that's all you do for number 1. Any questions? No?
No, I'm good. I understand it.
Okay, Emily, any questions? No? All right, and I don't see anybody, Trinity's not putting anything in the chat box. Okay, I'll keep going. All right, so for this one, like I said before, you can only add and subtract things that are common radicands. So if you notice, this 6 will match with this 6, so that means we can only add or subtract those two together. So I'll put boxes around these two. So we have 4 minus 3 that's in the front there. So that equals 1. So we get 1 square root of 6 for the boxes. And I'll change it to a different color so that you can actually see that these two will be the other two that are in common because of those 13s that are underneath. So when you add or subtract that, you get -11 plus 13, which is +2, and +2 goes in the front, and that's a 13 underneath. And because we got a +2, we're going to have a plus sign in between the answer from what we got with 1 square root of 6, and that's a +2 square root of 13, so we have a plus sign in between. So you can either write it one of two ways. You could write it square root of 6 plus 2 square root of 13, or it could be written as 2 square root of 13 plus the square root of 6. Either one is correct. So it's just depending on how they worded it in the multiple choice. It can be flipping, back and forth. It could be like x plus y or y plus x. It's the same thing. Okay. Can I go to number 3?
All right. Yeah, sure.
Emily? Oh, I got somebody in the chat box. Hold on. Chat, let's see. Emily said yep. All right, so number 3. Let's go, I'll go with blue this time. 7 square root of 5 minus 13 square root of 72 plus 4 square root of 80 minus 3 square root of 2. All right, so none of these radicands match. So we have to actually simplify this one and simplify this one. So the reason why we're not going to simplify the first or the last one is because there's no more simplification that you can do with those two. But 72 and 80 can definitely be broken down. So the first thing we're going to do is find the greatest perfect square that goes into 72. So remember, your perfect squares are 1 times 1, which is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and you just keep going all the way till you get to 100. So looking in that list, I know that 72, there's a couple ways to get to it. It's 1 times 72, 2 times 36, 9 times 8. There's all those different ways that you can do it, and 36 is one of our perfect squares. So I'm going to use 36 times 2 to break it up into it. And I have that -13 that was already in the front. So if I take the square root of 36, it's going to come out of the radical as a 6. Okay? So as you take the square root of 36, it comes out as a 6. And there's already a -13 out front, so you multiply that 6 with the -13. And the 2 can't come out because that's not a perfect square, so the 2 stays under. Then when you multiply -13 times +6, that's 6 times 10 is 60, 6 times 3 is 18, so you get -78, square root of 2. And then you're going to bring down that 7 square root of 5 because we haven't done anything with that yet. And now I'm going to work on the 80. So I have, I think I told you this yesterday for the, I think Emily, you said you came yesterday. I told you that there's a little hint. So they want you to simplify by combining like terms. So there's a 5 here and there's a 2 here. So we know that there has to be one of those two or both of them will have a match to be able to add or subtract with. So this 7 square root of 5 so far does not have a match, but this negative 3 square root of 2 over here has a match with the negative 78 square root of 2. So those two I can combine in the end. So that means my 80 must be the one that combines with the 5. So I know that I'm going to have a 5 that multiplies with something to equal 80. So I know that 16 times 5, I need to move this over a little bit. 16 times 5 actually equals 80. And 16 is one of our perfect squares. So when I take that 16 out, it comes out as a 4. There was already a 4 out front, and the 5 stays under. So now I multiply the 4 times the 4 and get 16, and I bring square root of 5 right next to it. And that's a positive 16 because it was a positive 4 from the beginning. I bring down the plus sign, and now I'm going to bring down my negative 3 square root of 2. So now I have everything simplified. There's nothing more that I can do except for finding the matches to be able to combine them. So I have 7 square root of 5 and 16 square root of 5 that I can combine. 7 plus 16 is 23. And then I have negative 78 square root of 2 and negative 3. So that's just like having negative 78 minus 3, which makes it more negative, which is negative 81 square root of 2. And like I said before, you can write it two ways. You could either have negative 81 square root of 2 in front and that positive 23 square root of 5 in the end, or positive 23 first and then the negative 81 second. Either way is correct. And that would be how you do that one. That one was the one that we had an issue with yesterday. So this one's a much better one because it actually, on the quiz, there are two that can combine that has one kind of Radicand, and then there's another two that combine that has another kind of Radicand. And the one we did yesterday was not a good choice, Mrs. Glenn, not a good choice. All right, so now we're going on to multiplying. That little symbol in the middle is actually a multiplying symbol. And with multiplying fractions, you just go straight across. The front times the top numerators times each other and the denominators times each other. So with radicals, you multiply the two front numbers by each other, and then you multiply the two radicands that are underneath by each other. So there is no front numbers for these two, so you just multiply the front, bottom numbers together. And 12 times 6 is 72. So that's the new radicand underneath, but that is not simplified, and it asks us to simplify it. So now we have to split it apart, and like we did on the previous one, we already know 72. The biggest perfect square is 36 times 2. So now if I take the square root of 36, that comes out to the front as a 6, and the 2 stays under the radicand, or as the radicand. So we have 6 square root of 2 is our answer. That was a really bad circle. I'm going to do that one again. There we go. Does my voice sound weird?
No, it's like a little scratchy, but other than that, I think it's fine.
Oh, okay. Because I, for like 3 days now, I've been having allergies. And so my nose is all dry from like blowing my nose all day. And I feel like I have like a raspy voice. Ugh. Okay, anyway. We're going to go to green because I like green too because of Clover, right? There she is. Are you going to make an appearance at the end of our Zoom? Okay, she said okay. All right, so we have distribution property where you have to distribute that square root of 2 into both of the two terms inside the binomial or inside the parentheses. So remember, the whole number goes out front and the radical goes second. So we're going to write that as 12 square root of 2 for the first one. And then you have two radicals times each other, so you just multiply the two that are underneath the radical. So you have 2 times 6, which is 12. So we have minus square root of 12. So this is asking you to simplify it. So we can't stop there. This 12 can actually be broken up into one of our perfect squares and a not perfect square. She just rang the bell again. My husband's going to be, he just took her out. Anyway, so we have 4 times 3 because that's the biggest perfect square. The only other ways to get to 12 would be 1 times 12 or 6 times 2, and none of those are perfect squares. So when you take the square root of 4, it goes out front as a 2, and then the 3 stays under. And then you bring it down and you get 12 square root of 2. And because this does not match the 3 over here, you are done. There's nothing more you can do. As far as you can go. You're stuck at the border. They will not let you cross to the foreign land. I don't know what I'm saying. I've been watching a lot of YouTube with, like I watched this before the quarantine or whatever, but there's like 6 different channels that I watch that travel around the world in a van that they've made into a home. And they've gone to Morocco. There's one person's in Morocco, or one couple's in Morocco. Another one's in Guatemala. Another one's in all the way down at the tip of the South America. And Emily, you are muted. Oh, you want to unmute? She wants to talk now. She's like, I'm ready to talk, Mrs. Glenn. Let me be free. There you go, Emily. You're free. So yeah, so I've been watching all of them, and then they've been getting like orders from their U.S. embassy for each country to come back to the United States, and then they have to decide whether or not they want to leave their van like in these foreign countries. So, and then they've been told like when they get to the border that they can't cross and all this other stuff. So that's why I'm saying foreign country anyway, because that's like on my brain right now. Like you care. Okay. So next question, is the simplified form 3 squared root of 2 minus 3 squared root of 2 rational? So remember, you subtract if they have common radicand, so the 2's match, but anytime you're subtracting exactly the same number that you have, so like 2 minus 2 is 0, 1/2 minus 1/2 is 0, a billion minus a billion is 0, so 3 squared root of 2 minus 3 squared root of 2 is a big fat 0. So 0 is what they're asking you, is 0 rational? Well, I want to draw you like a little picture so that you can figure out what's rational and what's not. So we'll put rational on this side and irrational on that side. So examples of rational numbers are fractions, whole numbers, zeros, terminating decimals, terminating or repeating decimals. And then for irrational, it would be square roots that you can't simplify. Let's give me, how am I going to write that easy? Like square root of 2, which is an example that you can't simplify. Pi is another example of a rational number. Decimals that do not terminate, so decimals that don't terminate or repeat. So what I mean by repeat is like if you get a decimal when you put in your calculator 1.3657904327765 and it just keeps going randomly and there's no pattern, that's irrational. But if you get a decimal that's like 1.2525252525, that's rational. So to be honest with you, like I said this in class before, rational happens more than irrational, just because there's a lot more categories in irrational numbers or rational numbers than there are in irrational numbers. So that's the difference between irrational and rational. You can also think about it like this, like irrational people go on and on and on and they don't make any sense. And rational people are people that make sense and you can understand them and then they stop talking eventually. Like, you know, they terminate is what I was trying to say. So a 0 is a rational number. So that is all you would do for this answer. Preguntas? No preguntas? No? Oh, Trinity,
No.
put your microphone on. Trinity, you unmuted? She's like, not really. Trinity, you're unmuted. Say hi.
Hello. Oh.
You guys are so nervous. It's cute. Okay. All right, so what was that?
Nothing.
Kennedy. Okay, so is the simplified form of 4 square root of 8 times 5 square root of 3 rational? All right, so like I said before in the number 1, we can only multiply like things together. So this front number, oops, I zoomed in. The front number times the front number is 20. And the radicand times the radicand is 24. So it asks us to simplify it. So 24 is not simplified because there is a perfect square and a not perfect square that equals 24. So we have 4 times 6 equals 24. 8 times 3, 24 times 1, 2 times 12. I think that's it. So out of those 4 choices, 4 times 6 is the only one that has a perfect square, 4 being the perfect square. So you get 4 and 6. And then 20 is already in the front. So when you take the square root of 4, that goes out to the front as a 2. The 20 is already in front. So you multiply that 2 with the 20. And then 6 is going to stay underneath. So now you have 20 times 2, which is 40. And square root of 6 would be your answer. 40 square root of 6. You all tired out? She's been playing with her toy almost this whole time. All right. What is true about the difference between, did we answer the question? Is it rational? So 40 square root of 6. So do you think it's rational or irrational? All of you guys have your microphones off so you can answer.
I think it's
Irrational?
irrational.
You think it's, who said it, irrational? Kennedy?
Yeah, well, I think both of us.
Yeah.
Okay, Emily and Kennedy, you think it's irrational? Trinity, what do you think?
Irrational.
Okay, can anybody tell me why they think it's irrational?
Because you can't simplify it, right?
Because you can't simplify what part?
The 40 and the 6.
Just
Like it
the
can't.
square root of 6.
Yeah.
So like if you look back at the table I made, do you see how it says the first thing on the irrational side is that you can't simplify that square root of 2?
Yeah.
So it's the square root of 6 that actually makes it irrational. Okay? And if you remember the rules on the guided notes, it said that when you multiply irrational with irrational, you get irrational. And you multiply irrational with irrational, you get rational. So if they're different, then it's irrational. If they're the same, it's rational. So this would be irrational. You are correct. So you would say, no, it's not rational. It's irrational. Swiper, no swiping.
I was thinking of that today. I was like, swipe for the fox. I missed that show.
Funny story. My sister, when she was little, she had an irrational fear of Swiper the fox. Like she had literal nightmares of Swiper the fox coming and swiping her out of bed.
Oh my gosh.
Like, it was kind of funny.
That's funny. How long did it take her to get over it?
Till she was 6.
Oh, wow.
It's kind of funny watching it. And I still tease her like, oh no, it's Swiper. And she's like, shut up. But I'm like, it's so cute. It's cute in a weird way.
I used to watch Dora the Explorer all the time.
I only watched it when I was babysitting because it was the only thing that was like entertaining to the kids I babysat when I was younger.
I also used to watch the Backyardigans.
I was a little Einstein's person, so I didn't really like Dora the Explorer. So.
Yeah, when I was a kid, it was Barney and Sesame Street.
Oh, I love Barney too. I would watch that all the time. I watch so many like musical shows. I think that's why I like musical stuff so much. Because all the shows would always like bust out into songs and dances, and I don't know.
Yep, same. Have you guys ever heard of Raffi?
No.
I don't think so.
So Raffi actually had like concerts that you could go to, and it was kind of like going to like a little kid concert, like a Teletubby concert or something. But it was this guy that would play songs with his guitar, and he sang like really funny songs like "I Like to Oat" opals and bananas, and then he would go through all the vowels.
Oh, that song.
I remember that
Oh,
song.
Yeah.
That one was actually in Barney
Yes.
at one point.
So we actually went to one of his concerts. I remember going as a kid because we used to sing those songs like all the time, and they're really funny. Like bringing a dinosaur to school as a class pet, and it was like I forgot what dinosaur it is, but like they're really goofy, silly songs that kids would like. And so yeah, those were the songs that I grew up on. Okay, anyway, so we have 5 squared of 11 minus the square root of 44. So remember, we can only subtract them if they have the common number underneath. So we have to break up this 44 into a perfect square, which is 4, times the not perfect square, which is 11. So 2 comes out front after you take the square root of 4, and 11 stays under. And then you get 5 square root of 11. So now we can actually subtract the front numbers. So that's 5 minus 2, which is 3. And the square root of 11 stays there. So your answer would be 3 square root of 11. But it says, is this rational or irrational? So which one do you guys think? Is it rational or irrational? That's not a choice.
I'm thinking. I think it's irrational.
Okay, Emily, what do you think?
That's what I was thinking, but I don't know.
And then Trinity?
I don't know.
Well, on the last one, you guys picked irrational because of the square root of 6. You couldn't go any further.
Yeah.
So on this one, can we go any further?
No.
Yeah.
Nope.
I don't think so.
So it's
No.
irrational again.
Okay.
And then I kind of blocked that I in irrational. There we go. Then I circled the A in and. Oops. Hand-eye coordination. There we go. All right. And then the last one, and then it'll be Clover's debut. Which statement is true about the product square root of 3 times 4 square root of 3 times negative 12, or square root of negative 12? All right. So we have to distribute that in. So anytime you multiply square root times square root, you got to multiply the numbers underneath. So that turns into 4 square root of 9, because the square root of 3 times the square root of 3, 3 times 3 is 9. And then square root of 3 times negative square root of 12 would be negative square root of 36. And then now 9 and 36 we know are perfect squares. So if you take the square root of 9, that would equal 3. So that comes out and multiplies with the 4. And then the square root of 36 is 6. So that just comes out and there's no square root anymore. So 4 times 3 is 12. And 12 minus 6 equals 6. So I put that on the line. And is 6 irrational or rational?
Rational.
It is rational because it's a whole number.
Yay.
It's all.
Wow.
Yeah.